and attendance. Okay. Autumn Smith. Hello, can you hear me?
Yes.
How are you today? Somebody has the name Otto. iPhone.
Yeah, how you doing, sir?
What's the name?
Arthur Lawson.
Last name. What's the last name?
Lawson, Lawson.
Lawson. Okay.
Yeah, I wanted to ask you concerning the classwork. I sent you an email asking if we can please resubmit some of our homework.
Don't say we or our.
Okay, me.
So I don't do group. Everything is based on individual students and
okay, me.
circumstance and individual student attendance. So I don't do class we or our. No, I don't do those. Okay. So
Okay,
speak for yourself.
Okay, I'm speaking of me.
So what is the question again?
If I can please resubmit some of my classwork, because usually
after the class I'm going to check. You say you send me an email and your name is what again? Lawson.
Yeah, Arthur Lawson.
So after the class I will check the email and then I will check your attendance, see how it looks. Everything depends on your attendance and participation. So that's why I do individual person, not a group. It's individual circumstance will qualify you or not qualify you. Okay?
Okay, sir.
All right. Let's begin. Today actually is the last day for us, the class. So you don't have to come to class next week. Okay? Keep working on your project and keep studying for the final exam. I want to show you a few things. If you look at my announcement, you see just complete the project and the homework. I will make the final exam available next week. I'm going to look at the school timetable, see how it looks, what they say, because everything depends on the school timetable, school for the exam. So, but I'm going to open it for next week. So what is left really is homework 10 and semester projects and then the final exam. So that's what we have left now. So that means homework 9, 10, you're already working on it. And project, I think I extended the due date already to this weekend. Excuse me. Yeah, last week I extended the due date, so you have more time to work on it. So you see, hope you can see the screen. Give me 1 minute. Let me put this person's name. It's Sharif. Okay, got it. All right. So if you look at the module, the project is due on December 10th. So I made the extension so that we'll be able to finish it and get ready for the final. This final, I'm going to open it next week for you and then do your homework on this topic we are doing tonight. Now, the topic we're doing tonight is called regression and correlation. Okay. So when you're doing the homework, you can either use calculator or you can use Excel. That's the way I explain it. Excel will give you the whole answer and then you pick and choose, the one that you will type in as your answer. Now, correlation and regression, they work together. Okay. They go hand in hand, I mean to say. Correlation is a statistical term we use to describe the degree to which two variables move together, move in coordination with one another. So, but regression, we use it to measure or determine the strength of the relationship between one variable and the other variable. One of the variables, we call them the dependent variable or the y variable. The other variables, we call them the independent variables or the x variables. Now, these are some of the questions we answer. Many questions are answered using correlation and regression analysis. For example, a business owner might want to know whether the volume of sales that are getting in a given month, whether it is related in any way to the amount of advertisements that they made. So you can use correlation and regression to figure that out. Now, also, educators might be interested in finding out whether the number of hours a student spend on their studies, whether they are related to their score in the final exam or in a particular exam. Stuff like that. Those are the things that we do with regression and correlation. Okay. So now the two variables, like I mentioned, there are two of them: dependent variable or the y variable. These are the variable. The y variable are the one that we can control. Things like, that we cannot control. Things like total sales, we have no control over that. Good health. I mean, we don't have a direct, we have indirect control. You can say, okay, I'm not gonna eat the right food, do exercise to improve my health. But you cannot determine the percentage or the quantity of improvement that will result from that action. Grades, yes, you can indirectly influence your grade by studying hard, but you cannot determine immediately. It is out of your control whether it is going to be A or B or C. Directly, it is indirectly going to, you can influence that indirectly by working hard, doing all the homework. But at the end of the day, we know after all your grades are added up, you can now figure out what you're gonna be. Anyway, I think we get the point. But the independent variables are the one that we can control. For example, we can decide to spend only 1,000 in advertisements. So we have control over that. Also, you can decide to eat only hamburger today, like dieting, or you can we want to study only for 1 hour today. So you have full control over independent variables. We also call them the X variable or the predictor variable. So in the business of correlation and regression, we are trying to get what we call the correlation coefficient. The correlation coefficient, that is the symbol we use for it is called the rho. See the symbol right here, rho. So the correlation coefficient is a numerical measure of the degree to which two variables move together. So we cannot get the exact rho, but you can estimate it using R, which is the sample correlation coefficient. Now here are the range of values for this sample correlation coefficient. It ranges from -1 to +1. -1 being that the two variables are negatively correlated or related, then +1 being that they are positively related. So you can see this chart here. If your answer, for example, is 0.5, that means it shows a positive correlation, but it's a weak one. See, the closer it gets to 0 is weak. The farther away it gets away from 0 is strong. For example, if you get something like 0.75 or 0.8 or 0.9, that means strong, positive linear relationship between S and Y variable. The same thing on the left side, if it's in the middle like this, it's a weak one. If you get 0.3, for example, it's weak. But if you get 0.85, that's a strong negative linear relationship between the two variables X and Y. Okay. So look at this, how we can now interpret it. So if it is from range of 0 to 0.2 is very low, and 0.2 to 0.4 is low, 0.4 to 0.6 is moderate, 0.6 to 0.8 is high to high, but strong is 0.8 to 1. Anyway, so now how do we show this graphically or pictorially? How do we show it graphically or pictorially? To do that, we use what they call the scatter plot. A scatter plot is a visual way to describe the nature of the relationship between the dependent variable and the independent variable. The dependent variable y and the independent variable x. We can have multiple independent variables, in which case we can say x1, x2, x3, but you have one dependent variable, yeah? One dependent variable. In that case, if you look at this, if we plot the points, if it appears like this, you see it is trending up. We say we have a strong positive linear relationship between x and y. For example, it means that when x increases, y also increases. For example, the higher the hours, the longer the hours you spend studying, the higher the final grade. So when one increases, the other one increases. Now, if it is in this form, that means it is trending down. This one indicates a strong negative linear relationship between s and y, meaning that when s increases, y decreases. So they go in the opposite direction. For example, the higher the speed, the lesser the time you arrive at your destination. I mean, assuming that you didn't crash the car, of course. Now, this one doesn't show any relationship at all. No relationship. Okay. Now, there's another concept we need to know about regression and correlation, what they call coefficient of determination R square. R square is a statistical method that explains how much of the variability of a factor can be caused or explained, by its relationship with the other factor. Example, I'll explain it when we start doing some example. Then you will understand it better. So for the regression equation, we use this. It's an equation that we use to show how the dependent variable typically acts when one of the independent variables are changed. So, in other words, the regression equation is a type of a statistical measure that shows us the extent to which we can predict one variable from the other variable. So this is, for simple regression, it looks like this: beta 0 plus beta 1x, where of course that x is the independent variable and y is the dependent variable. So the B0 is for y-intercept, B1 is for slope. Now, for the multiple regression, it's going to be longer than this, but we're going to do it today, just in a few minutes. Now, the slope here tells us the rate of change. We will see that when we do an example. So now, having explained all these concepts about regression and correlation, we'll start with an example on simple regression. Okay. This is I'll call it formula for simple regression, okay? So simple regression, simple linear regression. Now, to get all these variables, we need to use these formulas to compute them. This can take you like 2 hours if you want question. Or let's say that you are smart, you are a genius, okay? Let's say 1 hour, a genius. But that is if you don't make a mistake. So, to avoid that, we use Excel. Excel will give you the result in 3 minutes. And of course, less mistakes. Now, and after that, we can now test the significance of the correlation coefficient. So we can calculate the correlation coefficient R using this formula or this one here. Then we can now test the significance. All this takes time. That's why Excel was a lifesaver for most statisticians, because some of this work, like multiple regression, might take you the whole day. If you have up to 3 variables, if you have up to 4 variables, assuming that you didn't make any mistake. So with Excel, you can finish them in a matter of minutes and then interpret the results. So let's try one example. This one here doesn't contain all the equations. So let's go to this one here. But before we do that, I want to explain about the testing for the significance of the regression equation. For that, we use two methods. Of course, the traditional method where we use the t-test, and then the p-value method. For this class, we'll be using the p-value method. But Excel will give you all the results anyway. So both for the p-value and for the traditional methods. If you're using the traditional method, this is the test statistic right here. And then you check your answer to the table of the correlation coefficient. Excuse me. All right, let's do this one. For the p-value method, there's one more thing. Excel will give you the results for R, but it will not tell you, I mean, if you use the Excel output, it will give you the result for R, but you always give it in a positive form. So you will not even know whether it's negative or not. So for that, we use this Excel function, call it Courier function. That will give you the answer as a negative value, if it is a negative value, or if it's a positive value. Otherwise, if you want to rely on the output, in that case, the only way you can figure out if it is negative or not is by looking at your scatter plot. So anyway, to make sure that we get it correct, we can just use the Courier function. Where it's Courier array 1 and array 2, where array 1 is the range of data for the first variable, and array 2 is the range of data for the second variable. So let's do it. Let us do it. Hope you're ready. Before I do it, does anybody have a question so far? Any question yet? All right, good. Excellent. Let's solve this question. Which might see in the table below shows the mileage and prices in thousands of 8 cars in a car mart. So everything here is in thousands. For example, 21.8 means 21,800. And this 16 means 16,000. So everything is, I removed the zeros to make it simple. Mileage and price. It said, construct a scatter plot for this data. Calculate the correlation coefficient R. Compute the value of R squared. Explain your results. Find the regression equation. Okay. Then it says, what will be the predicted price for a car with 45,000 miles? Is there a relationship between the mileage and the car price? Use alpha 0.05. So let's do this. Of course, the first thing is the data entry part. To put this in Excel, I'm going to highlight. So when you're highlighting, remember to not include the label. You will type the label later on. Sometimes when you copy all of them with the label and put them there, it might get mixed up in Excel, cells, and you start making adjustments. But then time is going, and you lose some valuable time. So start from the numbers only. Copy this. After you can type these titles. Okay. Now put it in Excel. So we go to Excel. Okay. Put in Excel. I open my Excel. And then paste it here. Okay. Then for this side, I think is the mileage. Let's see. The left side is the mileage. Okay, good. And this is the price. So we go back to Excel. So we got mileage, then price. Hope you can see this very well. I'm gonna make it a little bit bigger. Okay, good. Now, all right. So mileage and price. So now let's get the output first. Then we can be able to answer those questions. To be able to answer all these questions that they asked us here, all these 6 questions, let's go the output. Okay. So you have it in this form. Go to data. Then data analysis. You can see my hand, data analysis. Click on that. Then you have to choose from here for the regression. Choose regression. Click OK. Then for the you see where they wrote input Y range. This is your Y right here, the price. Because you're trying to figure out the effect of the mileage on price. So the price, see, so click on this and then copy the input for the price from price all the way to the last number there. Okay, click here. For input S range, go here and then copy that. See that, remember that when you notice that as I'm copying it, I'm including their titles, which is the label. That's why that means I'm gonna check label here to show that I included the labels. Now for the output range, I'm gonna put the output below it so we can have more room. Now I want them to plot the line of fit plot and the residual plot. Yeah. So I check both of them, then click OK. I see they have the plots here. So I don't really need the residual, so I'm gonna delete the residual plots. So you can see the results. Now we can, with this, we can answer the questions they give us in that section. The first question says, construct a scatter plot. Okay, about A, part A. So let's see the scatter plot right here. Oh, we don't have enough room, so I'm gonna move this down. So we have our scatter plot already. Excel have done it for us. See, so all you gotta do is to move it up. Click here. Once, then see Control C, which is copy. And then go to your workbook and paste it. Use it by pressing Control V. You can see a scatter plot right there. Make it bigger. Now you can see that it is trending down. If you remember what I said when we started, I mentioned that if it is trending down like that, if you look at this one, if I showed you earlier, it's trending down. And that is how our scatter plot looks here. Trending down. So that means that the interpretation of this, okay, the scatter plot indicates is negative linear relationship between the price, the mileage, X, okay, and the price of the car. Of the car, Y. It means that as the mileage increases, the price decreases, and vice versa. Any question on this? Any question?
Yes, sir. With this Zoom meeting, I'm speaking of the class now. Will it be recorded that we can watch it later if you want to?
Oh yeah, sure. Yeah. You want me to put it?
Yeah, when we done.
Yeah, that means after the class, I'll put it in the I will post you an announcement with the link so you can watch it.
Okay, sir. Thank you.
You're welcome. So now let's answer part B. Part B says, calculate the correlation coefficient R. See, Excel have already done it for us. This is our R right here. can see right there. See multiple correlation R. See R here. So I'm gonna make all these numbers to be 3 decimal places. If you like, if the equation say make it 2, then you make it 2 decimal places. How do I do that? I highlight it and right click on it, choose. Well, you know what? You can do it directly from here. I go to the home page, so highlight it. I can see the key, right? You can just click on this side, this say decrease decimal, right? I usually like to use this. Right click and then format cells and use number, make it 2 decimal 3. I use 3. You can use 2 if you want, if the equation say use 2, okay? So you can see the R regression is right here. R, multiple R, see? Our R is right here. 0.758. 0.758. Which will be, I'm going to write it down here, 0.758. B, B equals R equals 0.758. But the problem is that it didn't tell us whether it is positive or negative, right? It just tells us this. So, but the charts show that it is negative, but the value the output gave us didn't tell us that. So to verify that, we can just use the Correl function. Remember I mentioned that the Correl function. Here, I think I mentioned it a few minutes ago here, the Correl. So now let us try it to make sure that we have everything is good. Otherwise, you can go with the output and use the chart to determine it. So we can use the Correl. See here, equals, let's find R, confirm it. Okay, but equals, and then you type, let me see, you can see if I'm seeing this. Okay, good, you guys are seeing it. You can just type equals Correl. It will pop out, double click on it. Array 1 is the first variable, comma. Array 2 is second variable. Enter key. See, it gives you the negative. See, it is giving the answer. You can see that it's negative. That we can, say negative 0.758. So that means that our answer is negative, and which confirms what our scatter plot showed, that it's a negative. See right here, it shows that it's negative. So this again indicates a negative relationship between the two variables. How strong is this? So let's go to the charts where I explain to you how it can be traced. I mean, 7 is strong. I believe it is strong. High, see high, see from 0.6 to 0.8 high, moderate high. So anyway, it is a strong positive negative linear relationship between S and Y. So this indicates interpretation of this. The correlation curve, the R equals negative 0.758. Shows a strong negative, I would say moderately high. Okay, let me put the moderately high. Moderately high negative linear relationship between the mileage and the price of the car. Any question on this one? Yeah, good. No question. Good. Excellent. Now, next question says, compute the value of R square. Explain our result. Well. The thing is that Excel has already done it for us again. R squared from Excel equals, if you look at what we have here in Excel, see what we have, R squared right there. Let's see right there, R squared. R squared is 0.574, 0.574. 0.574. Now, what does this mean? It means that about 57.4% of the decrease in the price of the car is explained by the increase in mileage. Interpretation. Okay. The R squared of, okay, put this way. The R squared of means that about 57.4% of the change in the price of the car, whether it's increase, but in this case is decrease. Of the decrease, if it is positive, that means if the R is positive, then it will mean increase. Or to be in a general, make it general, 57% of 57.4% of the change I'm going to make it general. You cannot decide, right? You're gonna use increase or decrease. Depends on the R. And the price of the car is explained by the change in the mileage. A question on this? Yeah. Excellent. All right. Let us take a answer the fourth question, which says find the regression equation. Very good. Now, the regression equation goes this way as per D. This is for simple regression. For this simple regression, okay, the regression equation is written as follows: y equals b0, which is this intercept, y-intercept, plus the slope b1x. Okay, b1x. So where the bo is this y-intercept and b1 is the slope. So in this case, to use this, we need our bo and b1 to be able to get the regression equation. So we need our bo and b1. The good news is that Excel already had that for us. So let me pick it to the Excel, and we can get this thing out from the Excel. bo and b1. So going to the Excel, we have our, see right there, you can see the where you have this, let me make it, see why they wrote coefficient. See, this one is your b1. See the b1, the intercept is the b1. Let me make them 3 decimal places. So using 3 decimal places here. See, so this one is here b1, b0. This one is a b1. So let me write them down. b0 is 17.100, and b1 is negative 0.09. Well, so a matter of fact, since zero after decimal point doesn't really whole significance. So make it like 17. Okay. So now let's go and put them in the formula to get our regression equation. So B0 is 17.10 and B1 is negative 0.09. So that making our regression equation be our regression equation to be, okay, y equals, now for B0 we put 17.10. For the B1, negative 0.09. Okay, x. That's our regression equation right there. So, see. So now, how do we interpret this? Interpretation of this. Okay. This means that, of course, when you look, if you remember when we started, I mentioned that all these are in thousands. Excuse me. Thousands. See? I mean, 21.8 means 21,800. 34 means 34,000. So here, 0.09 here, how many, what is it? So you gotta multiply it by 1,000, which you can have 0.09 times 1,000, okay? 0.09 times 1,000, 90, see? So that will help us to interpret that slope, okay? So, and it's negative. The slope value of the slope value of negative 0.09 and the regression equation means that the price of the car, the price of car now is negative. That means we're gonna use that it decreases. Decreases. If it's positive, we say that it increases. Decreases over time at the rate of $90 per 1,000 increase in mileage. So that's how I interpret it. Any question to that? Excellent, excellent. Now, let us go for the fifth question that they asked there, which is, what will be the predicted price of a car with 45,000 miles? Remember, all these are in thousands. So 45,000 miles means 45. So we're gonna use for 45 for the 45,000 miles to make the prediction. So what is the predicted value? To the predicted price for a car with the 45,000 miles. So let's use in that case, we have our regression equation, right? That is part what part is this? Part A. Okay. Let me look at the question again. So what is the predicted price of a car with 45,000 miles? Okay, good. So we have it here. We have our regression equation. This is part E. In this case, X equals 45,000, which, like I say, we're gonna use that as 45, to represent that. So that means Y in that case, the price, Y would now become equals, plug in 45,000, 45. That means 17.10 minus 0 0.09 9, then put 45 for x. Okay, equal. So I'm gonna write this down and we can figure this out. Y equals 17.10 minus 0.09 times 45. Okay, and that will give us the result. So we can figure this out from the calculator that we have. So that we have 17.1, okay, minus 0.09 times 45. That means 13.05, which means 13,050. 13.05. Okay. Let's go and put it, since everything is in thousands. So 13.05. So how do we interpret this? It is when we are doing the interpretation that we include 1,000. Interpretation. We can say that the predicted price for a car with 45,000 miles is, okay, have 13,050. Any question on this? Excellent, excellent. No question, good. Let's look at the last question there. It says, is there a relationship between the mileage of the car and the car price? Use alpha 0.05. Oh, yes. That is where you have it on this section. Oh, excuse me. First thing is to state the hypothesis. Okay. Yeah, and then the rule is the null hypothesis rule is that this is part F. This is part F. Okay, it's F. Null hypothesis is that the car price and mileage are not linearly related, and the car prices for the alternative means that the rho is not equal to 0, which means that the car prices and mileage are linearly related. So since they're testing for alpha 0.05, Excel usually uses by default use as alpha 0.05. Otherwise, you will put it when you are doing your putting your regression formula. So here significance see by default it uses 0.05. Okay. You can see that it's 95%, see 95% on both sides. So in that case, what is our p-value here for the mileage? See, you can see what we have a p-value. Let me make it see, I'm gonna make it 4 decimal places. Okay. You can see the p-value 0.0294 right there. So our alpha 0.0294 is a p-value. 0.0294. We can put it here. Okay, let's make a decision. Okay, decision. Alpha is this, then p-value. P-value. I haven't forgotten what I just read now. Let me go back and read it again. The p-value is our decision. The p-value is let me go and get it again. I forgot it already. P-value is 0.0294. Okay, 0.0294. 0.0294. So now, since the p-value is less than alpha, we reject null hypothesis. Reject null hypothesis. Reject the null hypothesis, which is HO. because the p-value of, excuse me, let me move this so we can have enough room. Okay. The p-value of, excuse me, the p-value of 0.0294 is less than the alpha value of 0.05. See? So we reject it because of that. That means we are rejecting the hypothesis, meaning that we are accepting this one, or not completely accepting it, but at least there's sufficient evidence to support the claim that the car price and mileage are linearly related. So conclusion now becomes, conclusion: there is sufficient evidence to support the claim, okay, that the car price and mileage are linearly related. Any question? Any question for this? Good. So now that's how you do the simple linear regression in Excel. I use it to answer questions. Now let us go look at multiple regression. Multiple regression is a lot of work, simple and more work on it, but we're going to stop. We're going to do only the part that involve just to get the regression equation and use it to make prediction. That's where we'll stop on that. And we're not going to go back all the way down to making big analysis, okay? Just to get the equation and use it to make prediction. So when you get the chance, you can practice the ones that I showed you here. You can do this as a practice at home. Let's look at multiple regression. Now, multiple regression, okay. Yeah, here. So what we do, we use more than one independent variable. That's why they call it multiple regression. It has more than one independent variable. So we use it to explain the variation in the dependent variable of interest. For instance, a grocery store owner may want to know if there is a relationship between household milk consumption, how much milk a household consumes, and the number of the amount of income they make and the size of the family. Say two variables: income of the family and the size of the family. How does it affect the quantity of milk they consume in a month or in a week, or, so we can try that. So that's basically what we do in a multiple regression. You have two or more independent variables. So the regression model, the multiple regression model goes this way. This is how the regression equation is written, where we have k independent variables. So you have the regression equation y equals b0, which is the intercept, plus b1 x1 from if it is simple, we stop around this, but it's a multiple, plus b2 x2 plus all the way to the last independent variables, where y represents the predicted value of y, given that the values of s1, s2, sk. So these values x1, x2, all the way to the last xk represent the independent variables of interest. And the k simply means the number of independent variables in the model. BO is the intercept. B1 is the average change in the y due to 1 unit change in x1. with x2 and x3 or x-k hold constant. Again, for example, B1 is the change in this y for a unit change in this one with x2 and sk constant. Now, B2 is the average change in y, okay, for each change in x2 with x1 and sk constant, just like that. And bk is the average change in y due to one unit change in x2 using x1, x3, constant. Now let's see how it works. How do we identify the regression coefficients? But unlike that, they predict change in the dependent variable due to one unit change, which can be increase or decrease in either of them, while other variables are held constant. So now, let's try this example here. Okay. Let's try this. Okay, it says a dairy, right? In a dairy, no way dairy now where they make milk. A dairy cooperative want to examine household milk consumption, Y, in quarts per week, based on the annual household income, X1, which are measured in thousands per week, per year, how increase in thousands, okay? Anyway, and the size of the family, X2. So he has data on 15 randomly selected families. And these are shown here. You can see the family serial number. You can see the milk consumption in quarts, which is the Y variable right here. And see if this relates to the income and family size. It says use the data, the above data to answer the following questions. Find the regression equation. Interpret the regression coefficients. What is the predicted milk consumption for a family with annual income of 50,000 and the size of 4 people? So again, for this one takes a longer time than the simple regression. So Excel again make it easy for us. As you already know, the first thing to do is to put our numbers in Excel. So I'm gonna open a new workbook here. I'll call it workbook 2. See, and I'm gonna increase so you can get good. So I'm going back to that. So the first thing again is the data entry part. You can highlight from here. Remember, you don't include the serial number, just the actual data itself. After, you can type on the titles here. So I'm gonna highlight it. Control C to copy it. Then I'm going to Excel and then paste it. Okay. Control V. Then now I'm gonna put the titles. Okay, so let me go and put the titles we have there. We have the first one is milk consumption in quarts, the income. So we got I got milk consumption in quarts. Then next one is the other one is the income. You have this right here. Then income. Now we have for that second part, we have the income as, say, income 1,000, then family. Income 1,000, okay. Family size. So we got income. Okay. Thousands. Then next is the family size. Family size. Okay, I'm gonna click on here and then make it family size. So I'm gonna highlight it, to make it look good. So I'm gonna make it bold again. Make it bold. Okay, good. Now we're ready to do work. We're ready for work now. So let me make sure I have everything copied correctly. I always like to double check. Yep, everything is good. Now, let's do the work. So now, again, you go to your data first, then data analysis, then of course regression. Click OK. Now this time we're using first of all the let's start all over because it's showing because we just did one example for the linear it is the same workbook that we use for linear regression, simple linear regression. So I'm gonna clean this here, clean all this, okay, uncheck them, okay. So clean, so it will leave us alone. So we can now choose what we want to choose. Good, clean everything, okay. Now, we can now go here. See input wire range. I'm gonna click here and start from the label all the way to the last digits here. Okay. Click here. And for the input X range, I'm gonna highlight the two X ranges, two of them together. See, I highlighted the two of them together. So I'm gonna click here. Then choose labels. Since I include labels, 95% by default, it has 95% by default. Anyway, output range. For the output range, I want to put it right here under it. And do I really need line of fit plot? If I put it, we plot many line of fit plot. I don't need that. Well, for this class, we are stopping at just getting the regression equation, you know. So and just click OK. See, it gives us the results. You can see the intercept, income, family size. Okay, and you can see the coefficient right here. I'm gonna make them all 3 decimal places. Okay. Now, this is the intercept. This one is the slope, and this one is the other two slope parameters it has. See? So let's write it down then so that we can get our regression equation. Okay, let me write this down. So I have BO as negative 11.503. B1, which is for the income, is 0.399. And for family size B2, we have 4.526. Like I said, we're not going to start testing hypothesis on this one. I mean, we can do that. I mean, it's part of the same thing we did on the linear simple regression we do on multiple, but we don't have the time anymore. So we just stop at predicting, getting the regression equation and using to make prediction. So the first answer we have, see the regression equation now becomes y. I'm gonna make it big. Make this 18. Okay, is y equals. Since we have our, let me write them down here. Let me adjust this. We have a B0. Okay, B0 equals negative 11.503. B1 equals 0.399. So B2 equals 4.526. So when we plug this in, we can get our equation as negative 11.503 for B1, because remember the equation is like this: B0 plus B1x1 plus B2x2, you know, all the way to the last independent variable. So we have our B1 equals to 0.9399. Oh, excuse me. 399 x1. So I'm gonna use this plus. So there's a plus sign here. So this is x1. Then this b2 is 0.4. 0.4, sorry, 4.526 x2. So you can see that from there. Okay, x1 and x2. So, and I want to pay a particular attention on how these are interpreted. For this one, negative 11.503, we might be tempted to interpret that as that the mere consumption for the family with zero income and zero family members. So that means that when there's no, the family don't have no income and no family member, they consume negative, because all this are in quarts, negative 11.503 quarts of milk. But that's not the case. That's not, remember, I think these are all in thousands, I believe, right? It just say quarts per week. It didn't say whether it is thousands. It just say quarts. Okay. Now, you'll be tempted to do that, but that's not negative value. Doesn't that mean that basically you mean that if the family have no income and no family size, no family, no member, they consume no milk. Now for the 0.399x1, this 399.3999 means that it tells us that the additional $1,000 because it's a positive number. So for additional $1,000 increase in annual income, household, holding household size constant, then that family will increase. I mean, their milk production will increase by an average of 0.339 quarts per week. What it means. And for this one, 4.5, that is this for family members. Well, this one means that it tells us that for each additional family member we have, right, then holding the income constant, then the family milk consumption will increase by an average of 4.526 quarts. Yeah. So that's how we, interpret the multiple regression equation. Now, we answered part A and part B. That's part in the interpretation. Let's look at part C. Part C says, what is the predicted milk consumption for a family with an annual income of 50,000 and family size of 4 people? See? Okay. To do that, we are looking for that. We are looking for this. The predicted milk. Okay. Now, in that case, first of all, let us get our regression equation down to that section and then make our prediction. Okay. Now, so we have remember we have our, say for 50,000 people. I'm sorry, for income of 50,000, I mean X1. You have our X1 equals 50,000. And we're talking about a family of 4 people. So X2 equals 4. I'm going to make it bigger so you can see this. Okay. So X1. So now we plug it into this formula. We have Y. Make it bigger. I'm going to put Y equals this, then plug this for S1. I'm going to change the S1 to 50,000. Okay. And X2, I'm going to change it to 4. And let's see what the output will be. Want to tell me it would be? I mean, what the output would be. So I'm going to write it down. Y equals negative 11.503 plus 0.399 times 50,000. Okay, plus 4. 4.526 times 4. Yeah. So let's go and put this in the calculator and get our results. We go and put this in the calculator. Have clear this. Negative 11.503 plus, you got this in parentheses, 0.399 times 50,000. Close it. Plus, you got 4.526 times 4 people. It's gonna be 19,000. Yep. That's what he says. 19,000. Actually, 50,000. Remember, this is $50,000. Now, if you remember, I want to show you something before we can put. We're not gonna put 50. I'm gonna put 50 because remember. Oh, excuse me. I'm gonna put 50. Because if you remember here, the income we are all written, and this one is 45,000. So I remove the 3 zeros. So I'm gonna remove the I put 50. I didn't remember to remove that 2 zeros because there's 3 zeros. Gotta be 50 right here. Okay. But the answer, when we read the answer, we now include the 1,000 part of it. Okay. So I'm gonna take you there, and then we're gonna make that adjustment 50, so that it will give us the actual number. Okay, 50. 26.56. You have 26, this is 50. 26.563 are watts. So we got 26. The predicted milk production consumption for a family with an annual income of 3. Remember, we have this 26.563 watts. So the predicted income, the predicted milk consumption for a family that with an annual income of $50,000 and a set of 4 is 26.563 watts. That's how I interpret this. Question on that? Any question? All right. Since there's no question, the class, I would say, feel free to log out, and we are done. For go and continue with your project and homework and prepare for your final exam. Okay. Hello.
Thank you, Professor. Are you going to be uploading this video? I'm
Yeah,
trying to keep up with the Excel stuff, but I got some of it down. I just want to go back in and.
Yeah, I'm gonna post the video in the announcement, so you can the link there, so you can get the link from there and watch it.
Okay, thank you.
You're welcome.
And for any final questions, we can email you.
If you have a question, you can email, of course. Yeah, sure.
Okay, thank you.
You're welcome. All right, guys. I guess next week I'm gonna put the final exam, and I wish you all the luck. Remember, no need to come to class.
Thank you.
You're welcome. No need to come to class on Monday. On Tuesday. Yeah, just get ready for your final. Okay? You guys have a good night.
I have a question before we get off.
Sure. What's the question again? Go ahead.
Oh, hold on. Oh, attendance. Since you marked me down for attendance for today, can you allow me to do my homework and the test one?
What do you mean? Test one is I don't give
so last week
that test is passed. It just was a test is different from homework. Test one we did it when? Like 2 months ago? Are you asking about it today?
Yeah, because
sorry about that. Sorry about that, though, but I can't go back to that test anymore.
Okay.
If your attendance is good, I can give you some second chance on the homework. I can reset it for you. But tests, I don't do that for tests, okay?
So last week we talked, and because my attendance was below 75 at the time, you said no, you will not allow me to do it because I never did the test one and I never did one of my homeworks. So that's why
So
I asked.
you are Lawson, right?
Say it again.
Is it Lawson? Who is speaking?
Just me, Tayon.
Oh, okay. Go ahead. Yeah, thanks. The homework when I put the attendance, it should go up, and that will qualify you for the homework.
Okay, so I'm confused. All right, so since I'm here today, my attendance should be above 75. So I'm asking, can I now do the test one I never did in that homework 7, I think that was, that I didn't do? If not, that's okay.
Homework, I have no problem with the homework. It's the test that I'm concerned because it's the 2 months past that we did that test. You never did at all? You didn't do that time?
Yeah, I told you I never did it on October 1st because it was a lot going on that week, so I never really did it. And we talked about it a few times. And last week you literally said you allowed me to do it if my attendance was above 75%. And
okay. Let's see. I'm gonna update the attendance as soon as we finish the class. I would like you to send me an email about this, right? So that let me check your name. Say what's the last
my last name is Lane, Lane.
I'm looking for your name here. But your first name is start with T, right?
Yes, sir.
Can you, I thought I saw it here. Can you spell it for me? The first name?
Sure.
T-A-Y-A-N, right? T-A-Y-A-N, right?
No. Tayaahon.
A-H-O-N. The last name is
Lane, Lane.
Oh, Lane. Okay. Yeah, let me check. Let me make things. Send me email. Don't forget. Send it on the email. The homework that one is a given. Once attendance move up, yeah, homework that will automatically qualify you for homework. But let me look at other things. Then I'll get back to you tonight about the test. Okay.
And then one more thing, it was also the classworks. I saw that you gave comments to some of my classworks, so I redid some of the classworks for you. And you did say you're going to review some of my classworks, and you did grade some of them already. I was wondering if you're going to grade the rest of them.
Oh yeah. I'll grade them.
All right, then that's no more questions.
I'll grade them. So don't forget, send me the email about this test thing. Then let me go through everything about your work, yeah, and then give you. But the homework, once your attendance, I put this attendance, and if it goes up, that will automatically qualify you for that homework to retake, and that's for you. For the test, I don't usually do that for tests, but I always look at your situation and then see what I can do. Okay.
All right. Thank you.
You're welcome. All right, guys. Have a good night.
Wait, I had a question before you go.
Who is speaking now?
Sharif,
what can I do for you?
Okay, so last week, I had tried to send you an email telling you I couldn't get on campus, and then I wanted to see if I could be excused from that class because I was having car issues, and that's I commute and everything. I don't live close to the school.
So you didn't come to class that day, right?
Yeah.
Yeah. I cannot give you. I cannot mark you present.
No. I'm not saying mark me present, but could you kind of excuse it because it wasn't a matter of me choosing not to come to class.
Of course, you know? You're excused. Just that I can't give you mark you present for that day because if you have to be physically present for that, but that you are excused.
Yeah. Okay.
It's not your fault, but to mark present, you have to be physically present. You know.
No, I understand that. I just didn't want it to go against me because it was one of those where it's I
No,
tried to reach out.
You will not.
And then I also wanted to ask you, when do you stop accepting work for the class? Is that this week or next week?
Don't say for class. You, like I said, like I told the other guy, I don't do group. Everything depends on individual circumstance and attendance. So you ask for yourself.
Well, for me then, since we on like my personal situation, it's a lot going on right now. So I probably won't be able to.
Let us first of all look at your
attendance. I got a good attendance.
Yeah, let me just look at it. They say, remember how you say it in science, trust but verify. I'm sure you must have had up. So let's see your grade. This is Sharif, right? Sharif, what's your last name?
Nagaya.
It starts with M, right?
No, it's an N.
Oh, N.
Yeah.
Okay. I hope I'm looking at the right page.
It's Nagaya.
I think I'm the wrong page. Okay. This is a different class. Let me open this class. Okay. Yep, that's you right. The 90s. Oh, good. Now, what you're gonna do? What you're gonna do now is send me an email tonight. The homework that you want me to put back for you. And
I don't think I'm gonna be able to finish
the homework. Say it again.
So I don't think like you can hear me, right?
Mm-hmm.
But I was saying I don't think I'm gonna be able to finish all of them and do like the work for my other classes. So I'm kind of on the verge of if I should just drop the class, or if I was thinking that maybe if I did a good grade on the Excel project, that's what I've been focusing on. And now that I know we have the final I just want to pass the class. That's kind of where I'm at with it.
Yeah, making it difficult for me here. I'm trying to give you work that you didn't do well, so you can redo them.
Yeah,
we have the whole of next week. But yeah, are you telling me you can't be able to finish them? Then there's nothing. If I give you, I mean, there's nothing I can do for you. Then if I give you, we have this week and next week, and I'm trying to give you the work that you didn't do well to put them back for you, so you can go and redo them and resubmit.
No. It's not like I don't do the work. I don't want to do the work. If you are open it, I'm gonna attempt it. But I'm trying to put all my effort now into the Excel project. And then I was saying like I still got other classes and stuff. So I know I missed a lot of the homeworks. So for me to go back and try to do all of that this week and then the Excel, I just don't want to put too much on me at the same time.
But we still have next week though. We still have next week. If you can do three, if I put them, at least you have from now till the 16th to finish.
Oh, it's to the 16th, not the 10th?
Yeah.
Okay.
I mean, I'm trying to help you out, not for everybody, for you. I'm trying to because
and I appreciate it. I don't want to, keep fighting, and then it's just like I'm not gonna pass the class regardless,
If I give you to the 16th, you can finish it for that, right?
What, the homeworks?
Yeah. And the class.
I'll attempt them to finish as many as I can.
In that case, Sharif, you need to speak to your academic advisor, see what they can do for you, because the only thing I can do for you is to give you second chance. And with that second chance, if you cannot get to finish the assignment, I don't know what else to do.
No, because I know I missed a lot of them. I missed a lot of homeworks, and that's what I was saying. If you let me redo them, I'll attempt all of them, but I don't think I'll finish every single one before the 16th.
I don't know what's there. That means you might not have to talk to your academic advisor. This is what I can do to give you the work too.
So
because of that circumstance.
Okay, can I ask a question now, Sharif? Are you done?
Yeah, go ahead.
I just want to make sure he was done.
Sharif, okay. I've already told him. I don't know what else.
Yeah. Are you done, Sharif?
So Sharif, are you gonna send me the email then?
Nah, she can go first because I want to figure out what I'm gonna say real quick.
No, I want to make sure you're done. Y'all just talking in circles. That's why I was trying to figure out if you were done yet.
Sharif, are you?
Nah, go ahead. You good?
Done?
You can go ahead.
Okay, then let's hear your question, ma'am.
No, when Sharif is done, I'll go. I don't need
Okay, Sharif, that's what I can do for you is to give you the right second chance, and then it's not up to you to get them done before the deadline. So the only any other decision that you want to make about it, you have to speak to your academic advisor. Okay.
Now I wanted you to look at my grade and see if I redid all of that, would that be enough to pass the class? That was kind of what I was getting at.
It depends on your score on them, the homework and the classwork that I'm gonna give you. Your score on everything, that's what this time that will determine. I can't determine. There's no way I can determine it here. Is when you guys grade on them, when I put them in, then you can have them. So I can't make up grades. That's the only way to determine is if you add the grades in. Okay.
You want me to see your email, right?
Yeah, the names of those assignments, so I can open them for you.
Okay, thank you.
You're welcome. All right. Ma'am,
Hey, Professor. Sorry
welcome.
about that. I think I lost connection at the tail end of the class.
What's the name
Can
again?
you hear me? Oh, this is Dominique Brown.
Oh,
Sorry.
yeah, okay, no problem.
So I just wanted to ask you because I know with Canvas sometimes that people say like don't look at that grade, but I just want to know, like, is that the right grade in Canvas?
Yes, it is the right grade. What do you mean?
Because it says I have a 63% overall.
Well, it's
Last name Brown.
Brown.
Mm-hmm.
I'm looking for your name. Okay, Dominic.
Yes.
Yes, 64%. Why? Because I have not seen. You can see them from. Look at how your grade are determined. Can you see the screen?
Yes, I can see it.
5% for your attendance and participation. Classwork 20%. Test 25%. Homework 15%. Project 15%. Final grades is 20%. So the projects that we have, you see all this score for the project is for the Excel assignment. Because Excel that are part of the project. I have not graded the main project. Now, homework, are you missing some homework? Because your homework average now is 49%. Are you missing some of them?
I'm not missing them. My scores are just low.
Oh, the score. Okay, the score. Okay. And I have not put in the final project. And is there something you want me to open for you?
If I could because I know I need at least a C to pass, for it to count for graduation. So I need to get it higher.
Are you graduating this semester?
No, but this is my second time taking this class.
Okay.
Because I got a D in it last time.
You got a B on it? So why are you taking it the second time?
Because they said that I can't get a business degree with a D.
Oh, D. Okay, so I thought you said B.
No, I got a D. Sorry, a D is
so like I was telling Sherry, what I can do for you is to, if you have any homework that want me to open for you, you can tell, because your attendance is good. So you have a 92%.
Yeah, I don't have a lot missing. Maybe the lower scores, if I could do like a redo one of the really lower score homeworks.
Yeah, you can send me email with names. I can set it for you today. Because you send me an email tonight, so I want to take care of all this today and tomorrow.
Okay. And you already graded everything else?
Yeah, there's the last Excel assignment. I have not graded it yet, and I have not graded the project yet.
The last one, the one that's due on the 10th.
The last Excel assignment I have not graded it, and I have not graded the project. So those are the two things I need to grade, and then I'll be done with the grading. So next is the final exam. You haven't taken the final exam, so you are still not too bad. So just tell me the homework that you are missing. You took both tests, right?
I don't know about that, but
no, you didn't the two test 1, test 2.
I took them. I don't know. I didn't do that great. I took
them.
Yeah,
but since that means the problem is from the homework and the classwork probably. So
it's the homework.
So you have to send me an email with that, the one that you want me to open for you. And then I'll do that.
Do we have class next Tuesday?
No,
No.
no. If you go there, you're gonna be alone, or home alone.
Oh, this is our last class.
This is our last class. You have time to work on your project and other stuff, prepare for the final.
If we have questions about it, can we ask or no?
Question about
The project.
well, I can answer some of them. Yes, I mean, but not all of them.
Yeah.
There's one part, the part I can answer, but there's some part I can't answer. The one I want you to do, by yourself.
Yeah.
Yeah.
Okay. Okay.
All right, sir.
Yeah.
Well,
So that's
All
it, eh? Don't forget tonight. Send it tonight, okay?
yes.
All right.
Thank you.
You're
Bye-bye.
welcome. Have a good night. Yeah.
You too. Bye-bye.
Goodbye.
All right, sir.
Yep. Have you sent email?
This is Arthur Lawson.
Huh?
Arthur Lawson.
Yes. I know who it is.
Yeah, I sent you. You saw the email now.
I have not checked. I will check it later tonight.
Oh, okay.
So, like I said, it depends on the individual circumstance and attendance. So I'll look at everything tonight or tomorrow. So I want to get all these things out of the way and then give you feedback.
Yeah, because for the class work, the reason why I wasn't able to complete it, also to get it done on time, is because I live Prince George County, and I go to school Morgan, and I have to commute because I can't afford housing.
But
Yes.
but now if you can't do it then, how can you do it now?
Yeah, because I'm home. What I'm saying is that, the class starts by 6, right? And ends like 8:30. And I have to catch the train by 9:30. So sometimes, most of the time, I always on the train doing the assignment. Yeah. Yeah, that's how.
It's a college, Mr. Lawson. It's a college. You still have whatever reason it is, you have 16 weeks to catch up. I mean, if you don't do it this week, you can still do it the following week. I mean, I'm talking about before now. I'm not talking about now. Now is we are only 2 weeks to end the class. But I'm talking about before. Now, if you can't do it then how can you be able to do it now?
It's only the class.
Are you not still commuting from Prince George's County to Baltimore?
I'm commuting, but for now, I don't have classes because most of my classes, like, they put it the same stuff like it's online. So I've done most of it. I've done most of it except for, I think, 3 or 4. That's all. I think 3.
3 classworks?
Yeah, 3 or 4 classwork that I need to get done.
And you put them on the email?
No, I didn't specify it because I submitted it, but he said it was wrong. So he said I should I think I have to resubmit it. That's why I wanted to let you know.
Okay, resubmit it then.
Okay.
Resubmit them then.
Is there any way you can open the homework in my lab?
Well, like I said, I'm gonna look for your see your email and then check everything about you in this class and see. Then I'll make my final decision. You're gonna hear from me probably by tomorrow. Okay.
Okay, sir. No problem.
All right.
Thank you.
You're welcome. Have a good night.
Bye.